Concrete. Highway construction calls for a lot of it, and it has to be high-quality material. If you could take the concrete out of this structure, what you'd have left would be, basically, a lot of reinforcing steel. From the bottom up, it's concrete. Piling, footings, columns, caps, beams, deck, and railing. We use concrete extensively, in bridges, of course, but also in pavement, culverts, barriers, and retaining walls. And the list goes on. Because of the various uses for concrete, there are different classes of the material. Each class of concrete is based on a different design. That's why testing is necessary, to make sure that the mix that was specified by the designer is delivered to the job site, and to make sure that the concrete is mixed consistently. A problem at the plant will show up in the field test results. That is why the inspector's on the job, to make sure the department gets the quality it pays for. Here are the major tests: temperature, slump, compressive strength, and air content. This program, Part 1, covers the necessary preparations, sampling concrete, and checking temperature. Part 2 covers testing the concrete for slump and casting cylinders for compressive strength tests. And Part 3 deals with air content tests. Okay, let's get going. Preparations. But first, a couple of quick notes. Before the work begins, discuss the procedure for sampling and testing with the contractor's representative. Make sure there's an understanding about the timing and methods of obtaining samples and running tests. Okay, before any concrete is delivered to the work site, make sure you're ready for it. For example, if you're patching, is the base well compacted? Stable? Are the forms and reinforcing bars in place? If the job is really well coordinated, the concrete will be placed as soon as the truck arrives. So check the job site and the testing equipment. You'll be running slump tests and air content tests. And you'll be casting cylinders. So make sure the equipment's on hand, in good shape, relatively clean. And for air content tests, make sure the meter has been calibrated recently. When the first truck arrives, the driver will give you a delivery slip. That's your verification that the correct concrete design is being mixed. Check the class of concrete and the water and cement content. Among other things, the delivery slip shows the amount of concrete in the truck, the time at which it was batched, and the reading on the truck's revolution counter. Double-check the class of concrete. Save the delivery slip. That's part of the project documentation. You get one for each load. The time is critical. Concrete must be placed within 90 minutes after mixing. So if the concrete was batched at 2 o'clock, it must be placed by 3:30. The revolution counter on the truck records each revolution of the drum at both mixing and agitating speeds. The concrete will start to segregate if it's mixed too much, so it's important to keep an eye on the counter. The counter reading on the delivery slip was taken when the concrete started mixing, if it was truck mixed, or when the concrete was placed in the truck, if it was plant mixed. Before the concrete is placed, read the counter, and read it again at the completion of the discharge. Then record the total revolutions on the delivery slip. If it's truck mixed concrete, it has to be mixed between 70 and 100 revolutions at mixing speed, and no more than 250 total revolutions, counting both mixing and agitating revolutions. If it's plant mixed concrete, there are mixing time limits for the central mixer. but the same 250 total revolutions limit applies for the hauling units, whether they're truck mixers or agitators. Okay, that covers preparations. Make sure the work site is ready. Check the testing equipment. It should be in good shape and recently calibrated. Collect all delivery slips and record the total mixing water added and the total revolutions on the slips. Now on to sampling. Getting a sample of concrete to run the tests on. Actually, the word sample isn't quite enough. What you're going for is a representative sample. You want to make sure the concrete that you're testing is typical of the entire truckload. The basic rule in sampling concrete is this: don't take the sample from the beginning or the end of the discharge. At least 3 separate samples have to be taken. I'd suggest taking them at about the 1/3, 1/2, and 2/3 points. Either catch the entire stream in a container or swing the chute over to the side. The important point is this: get the entire stream. Be sure to get enough concrete to run all of your tests without reusing any of it. Cutting the stream in half like this is unacceptable. The rim of the bucket will knock some of the large aggregate out of the sample. Remember, a reliable test calls for a representative sample. The sample should be mixed with a shovel, just enough to give it a uniform appearance. Then it should be covered to protect it from the sun and the wind. Don't let it dry out. One last point in sampling: check the time. You have 15 minutes to run the testing and cast the cylinders, if they're going to be made from this load. And that covers sampling. Now, temperature. Temperature affects concrete the same as it affects people. It can freeze and it can overheat. Neither is acceptable. In concrete work, temperature is always a concern, both the air temperature and the temperature of the concrete. Of course, the air temperature affects the concrete temperature, and the concrete can't withstand extreme highs or lows. In structures, concrete has to be between 60 and 90 degrees Fahrenheit. In paving, the range is 50 to 90. The concrete temperature determines the time allowed between batching and placing, and the air temperature determines whether to use normal curing methods or special cold weather curing. Checking the concrete temperature is simple. Just insert an approved thermometer into the sample, wait 10 or 15 seconds, and read it. Record the temperature on the delivery slip. That's all there is to it. And that completes part 1 of the series on concrete sampling and testing. Preparations, sampling, and checking temperature. When you're ready, go on to parts 2 and 3.